My name's David Murphy, and we're going to talk about where Mongo's going from here, but that taglines into where MySQL's going as well. So I'm going to talk about some of the differences in the ecosystem and then how it's all kind of converging and my thoughts on that. So a little bit about myself. My name is David Murphy. If y'all have not been to a Percona Live before, I was the practice manager for Mongo at Percona. So I helped build the Mongo business at Percona. Before that, I worked at Object Rocket as the lead DBA. Before that, I was part of Electronic Arts as the global architect for both MySQL and NoSQL stuff. So just a little bit of background on why I'm talking to you about this is I've been deep in the Mongo and MySQL and Postgres ecosystems for a very long time. There it goes. All right, so basically I wanted to cover a couple key points, and that was, I think there's a lot of misconceptions floating around that I see every time I'm at a Percona Live about what does JSON support mean in Postgres, in MySQL, and in Mongo. And I think it's important to understand the differences so that when we're thinking about the different technologies, we make sure that we're not just assuming everything's an even playing field, everything's gonna parse the JSON that you're storing in the same way. But then I also wanted to talk about the new license itself and what that means and what it's causing for people, which tangentially is also how it got dropped from Red Hat and Debian and what that's realistically probably meaning for a lot of stuff too. But then I wanted to talk about group replication and replica sets. If you're not familiar with group replication in MySQL, I'm going to kind of go over that a bit to help understand the differences between the two. And then finally, I'm going to cover where transactions are, where they're going in the future, so that you kind of understand some of the differences as well that we would want to look at. And then finally, I'm going to give you some thoughts on a couple other areas on where I think this is going and the concerns that I have for both MySQL and Mongo in the near future. Oops. So MySQL JSON, I wanted to start with that one. So in this one, there's a couple key rules that not a lot of people tell you. You should try not to do queries on JSON extract. You should try to use primary key lookups where you can. This sounds counterintuitive because a lot of people are trying to use JSON objects to do richer queries and stuff, but in reality, you're putting a lot more tax on your database, and it might be more efficient for you to ask your applications which scale out more linearly to answer those questions. So I'm not saying not to do it, I'm just saying understand the CPU implications of doing JSON extracts and other stuff means that you probably don't want to do that if you can avoid it, architecturally speaking. The other is constraints should be real columns. And what I'm saying here is, even if you have to duplicate some of the data that is in your JSON field, that should be a real column and not a virtual column. There are performance characteristic differences. And even if you say, I'm creating a virtual column and I'm creating it as a stored value, all this kind of stuff, it's still not as efficient as if I would have just packed it naturally. And then there's some interesting cases where in certain joins and certain subselects, if you were using a virtual column and you're indexed on it and you would expect it to work, it'll just do a table scan. Newer and newer versions of MySQL are trying to fix this, but there's still going to be edge cases for a while for anything that's new to the optimizer like this. And I think this is important because when I talk about Postgres, you'll notice the difference where this isn't the same case in Postgres. This is a MySQL thing. But some of the other aspects of it I want to talk about is it does use binary storage. So a lot of people, if they don't know a lot about MySQL, might say, oh, well, it's JSON, it's a string. It is binary storage, but that doesn't mean it's binary searching all the time. Sometimes it is still bringing that into a string context before it gets parsed. And that's exceptionally true when we start talking about the buffer pools, which if you're using heavy JSON, plan your buffer pools to be much bigger, 2 or 3 times as a ratio of the amount of data that you're holding in that JSON. because of the way that it needs to be stored as both the binary form and then a searchable extraction form. Just plan on that so that you're not purging out of your buffer pool more than you expected. And then I talked about JSON extract already. And then the other thing is, just in principle, I kind of talked about it earlier in the, you should use primary key lookups. Try not to project, try not to extract from your JSON content if you can. Oops. So Postgres is different considerably because it can index the values inside of the content instead of having to create a virtual column. This is much more efficient at the way it actually stores it behind the scenes and the CPU cost for pulling data. And also, because of this, your constraints can be in your JSON blob. So there's a structural difference. JSON's going to align much more to your Mongo design. Also, JSON-B uses a 4-byte padding. So where you might be saving some space on every single row if you're storing it in Mongo, if somebody's telling you to switch to Postgres, talk to them about this. Make sure that you've planned for this padding. Make sure that you've planned your shared buffers, which is like the MySQL buffer pool, accordingly, or you're going to have a lot of challenges. One of the most interesting things about Postgres, though, is this point here, where your updates, your journal entries, might cross actual block boundaries on Postgres. And when they do, the journal entries are much bigger than the journal entries that you would have in the MongoDB side. So your replication, your recovery stuff can actually be much more expensive in Postgres, but be hidden from you when you were just normally running it doing a benchmark. And so I think this is one of the really important things with Postgres, because too many people will just do some benchmarks. Looks like Postgres is a good number. Somebody in their organization really likes Postgres over Mongo, and they want you to move off of Mongo. Well, this kind of gets into the overall problem is it might be good in this one sense, but then Postgres isn't going to have a replica set. So the HA components of Mongo don't count in the same way. And so you want to balance these points, but if you just try to bring up the HA perspective, most of the time they're not going to listen to you because they've already kind of decided. And so you need to talk about the actual structural differences with how JSON is treated in each of these technologies. So I wanted to talk about that. I'll get to some more of the HA stuff when I talk about replica sets in a couple minutes. But I wanted to also cover the license changes. How many of you actually run some sort of public or customer-facing cloud in y'all's stacks? Okay, so you're the only one the new license actually matters to at all. Because what the new license basically is saying is if he wants to use Mongo, modern versions of Mongo, he has to open source his entire cloud-facing stack unless he goes and buys their commercial license. So it's actually quite an interesting new license. And the SSPL was launched, had a very negative reception. It got rejected, et cetera, et cetera. And these are kind of all the dates that things happened. But the interesting part is in March, where they actually rescinded their application with the open source initiatives. But they're still using this old license. They haven't come up with a new one. So if your company is telling you you should move off of Mongo because of this license, explain to them that if you don't think that you're going to build a cloud service, this isn't actually the risk that a lot of people think it is. Now, if your company is very pro open source, it might be a different risk where they want to be something that's more aligned to proper open source. And that's a different discussion point. But make sure that you're making the decision to consider moving off Mongo for the right reasons. And you're not just jumping to a conclusion that, oh, Mongo's no longer open source, we need to move off of it because it's no longer open source. It's still technically open source. It just has a more restrictive license than it did before. And so is there anything else I want to talk about that one? I do expect they're going to come out with another license. And they're going to try to make it a little more palatable for people. But ultimately, this comes down to, we have to look at what Amazon, Google have done in the past. Microsoft. They've cloned services from different companies and not paid those companies their due. This is what Mongo's trying to protect against, because at the end of the day, if you look at their analyst reports, they don't make that much money on their commercial support. They're trying to make money off of partnerships by doing this kind of change. So they're not trying to hurt individual companies not running clouds. They're just trying to get the big clouds to give a fair share to them. So I wanted to cover replica sets, because this is where we start getting into the future of Mongo, really, and where this collides with MySQL. So the first thing I wanted to point out about MySQL is, and Mongo, I meant to say, I meant to change the title on the green one, sorry. But data duplicated on nodes on both sides. The data is duplicated. Where the big difference comes in is Mongo has 50 replicas it can have, with 7 of those voting, and MySQL only has 9. And actually, when you look at some of the MySQL settings, there's a lot of things that you would need to change to go to more. By default, on the MySQL side, the auto increment offset is set to 7 when you're using group replication. So if you tried to make that number bigger by changing a hard-coded value, you're gonna have problems. So don't arbitrarily try to change that. That limit's there because it's not ready to be a bigger set. But this is also very important for anybody using Mongo, because this is a distinct advantage that Mongo has in this particular area. Another one is you have, in both cases, the code must retry a failover. And you might ask, well, Mongo, you don't have to do that. You can connect to a replica set, it'll automatically do that for you. It's not true in all languages. PHP, for example, does a very bad job of connection pooling and reconnection. So that's why I listed it there, but generally speaking, Mongo is much better on it. They both use, actually, Mongo uses Raft consensus rather than Paxos. It's slightly different, it's slightly simpler. If you want, you could ask me questions after this about the differences, but realistically speaking, it's all very internals to it. It doesn't make a big difference from a user's perspective. But they also both have autosync now, which is very nice. And by autosync, I mean, if I add a new node to a replica set, if I add a new node to group replication, the node will automatically get data synced from the other nodes. If a node falls out of the group for some reason and it comes back, they'll try to repair them. And this is very important because this was a major limitation of MySQL for a very long time and a major advantage of Mongo. But now it's gone. MySQL has matched that. And then all nodes hold the same exact data now. So then when we talk about Mongo, in context to replica sets and things like that, what we're actually talking about from an advantage perspective is it's slightly more efficient at accessing BSON data than even JSON-B, and it has sharding that MySQL doesn't have yet. So that's kind of the future of where that side of things are going. But the other aspect of it is now more transactions. So on one side you have sharding, and on the other side you have transactions, and sharding is very complicated to do. So prior to 4.1, 4.2, what we had in transactions is you had sessions that were added, which actually internally are a representation of a transaction in the WireTiger engine in Mongo. And then that's presented forward so you can reconnect to a transaction and issue more commands against it. And then it could start doing cross-collection locking, and most functions would work well with these transactions. But it wasn't shard aware. So if I wanted to cross shards, if I wanted to look at wide areas of data, I would have to have multiple transactions. Might not be what I want. Might not get accurate data because they're not run at exactly the same time in the same isolation. But you can get ACID-like behavior And I say that because when Mongo defines ACID, it's not what we mean when we talk about ACID in MySQL. It's what the literal definition of ACID is, which doesn't say that it has to be for a whole row. It can just be for a document. Only WireTiger engines can implement these transactions, which we already knew. Well, WireTiger-based ones. So the in-memory from Percona server is based on WireTiger, so it could use them, for example. But when we start getting to greater than 4.0, so 4.1 and 4.2, what we see is mmap's going to be dropped. We are going to have cross-shard transactions, but they will be extremely, extremely slow. It's going to be the highest level of write confirmation and read confirmation plus extra overhead. And even if you look at the JIRA tickets on it, they're just very clear. This is going to be very slow, but it solves a very specific case. So when people tell you, oh, Mongo's going to have sharded transactions, we don't need to worry about switching to MySQL because we can just do everything here and it's going to solve this sharding problem for us. It will, but if you really need transactions, Mongo is still not the best choice of technology for you to use. There's isolation level problems, and you can get around those with heavy tweaking of different settings, but the level of impact that you do ends up usually with less performance than if you would have just been on MySQL or Postgres. And as a result, it's a nice checkbox feature to keep Mongo in consideration, but it's not really a very usable one from an operations team's perspective. But they're going to do more on trying to improve resuming and failovers of transactions as well. It's basically shipping more transaction information over to the receiving replica so that you can kind of continue where you were at even in failovers. It works in sessions to some degree today. They're trying to improve it further. But also they're going to do more and more aggregation functions we're going to see, because this is where Mongo is going to try to separate from MySQL more to provide more and more OLAP-like stuff or HTAP-like behaviors. So what I wanted to talk about is kind of Mongo's view of the ecosystem, because this is really when we start getting to the future now that we've defined the differences. Mongo's view is this: they don't care that much about the database. They care about Stitch and the application SDK using Atlas to provision the database, and then you happen to use the database technology to help create a unified ecosystem. So when we think about the future of Mongo, that's the future of Mongo. Not really Mongo as a general purpose database, but as specialized fitting in their ecosystem is their primary goal. This means, and most importantly, they will create features and they will be useful for Mongo to be used as a general purpose. But first and foremost, they're going to create features that help that ecosystem evolve. And so the concern that I have for this moving forward for people trying to do general purpose Mongo use is at some point, we're going to start seeing optimizations made that are for Stitch. And when that happens, we might start seeing bad optimizer plans for when you're trying to do general purpose stuff. But they're not going to want to reverse those changes because it still helps the ecosystem that is their primary goal. So I just kind of wanted to keep that in mind for everybody, because what they're really wanting to do is stay developer-centric and keep those developers on small instances that are very automated and easy to use. Because their goal is not to have the 1 terabyte Mongo instance. It's to have 55 gig, 50 gig instances that the company doesn't even realize they have all 50. And it just kind of organically grows, and they have more and more install base and more softwares. That's what they want. There's nothing wrong with that. But as practitioners, we need to recognize that and kind of understand where that balance point is. And this gets to the really bad part now. And that is, there's a car crash coming in about 3 to 5 years. Probably closer to 3 in my opinion. And that is, if we look at the history, MySQL added JSON support. Then it added group replication, which was auto failover and recovery. which matched MongoDB's replica sets that it's always had. Then MongoDB added transactions because MySQL added a richly scriptable shell, much like the Mongo shell, which MySQL said was going to go towards building native sharding in the future, which, of course, was the one thing that Mongo had held on to is we have native sharding. You don't need to use third-party tools. We can keep this all in one simple ecosystem for you. And as a result, Mongo added more and more advanced aggregation functions to try to separate themselves, more integrations into things like Tableau and stuff like that to help, and Elastic to help people do things. But what we're doing is now Mongo's racing towards ACID and transactions at the same level of safety as MySQL. And their engine can do it. WiredTiger can get them there. But while they do that, the ecosystems are going to collide. And quite frankly, this picture is exactly the way I see it. Mongo is going to be the small car that is good for general purposes, and developers are liking it, but from a big C-level boardroom kind of perspective, MySQL is the name people know, and it's a much bigger fish in a bigger pond. And there's going to be an accident. They're both going to take damage. I can't say for sure which one's going to come out on top, but I personally think that what's going to happen is Mongo is going to fade into a specialist area, the same way Cassandra is, the same way Postgres is. They're not general purpose, they're specialists, and they're great at what they do for their jobs, but not for general purpose. And the reason I say this is when we get into all of it, the MongoDB license, while it doesn't affect y'all today, it is going to weigh heavy on those boardrooms. It is going to weigh heavy on lawyers and risks and stuff like that when you're trying to go to procurement. And so I think in the future what we're going to look at is we're going to have this, we're going to have an inflection point where they collide with each other. There's going to be one major winner, one that goes more to the minority area of databases. Neither is going to destroy each other, but it's going to be, there's only one spot to take the primary area of kind of the document store. Uh-huh.
Put it in the category of a non-general purpose.
Yep. And it comes down to an operations perspective. I'm almost done, so this question's fine. So it comes down to an operations perspective. Postgres is a great database, but it requires a much deeper understanding of how databases work than, say, MySQL or Mongo does in general. And so it's not that it's bad at general purpose, but to use it generally from a support team, it requires specialty knowledge and a different skill set of DBAs and stuff like that. And so it just comes down to that, especially when we consider things like Postgres, like the extensions and the modules and foreign data wrappers and all of this stuff. It gets very complex very quickly when you start bolting on those other amazing functionalities of it. And so what I was going to say about Postgres and all of this, the only reason Postgres is not really in this conversation here is Postgres hasn't said or done anything that makes me think that they're going to really bring together PG Bouncer and the other things to bring sharding and connection proxies together to start battling in the same arena. I think they don't care about battling in that arena. They're more concerned with more significant database problems and fixing the flaws that MySQL has done by catering to users as opposed to catering to the right way to build a database. But that's all I had. I didn't know if anybody else had any other questions. Yeah, don't get me wrong. I like Postgres, but there is a reason that when it and MySQL started at roughly the same time, MySQL took over, and that was because the Postgres architects were like, this is the right thing to do, and the MySQL architects were like, yeah, we can add this feature. And so ultimately, they got more crowdsourced, and Mongo did essentially the same thing when it evolved and it launched to be developer-centric. It replicated in the cloud-native era what MySQL had done in the old infrastructure era. All right, thank you. Yeah. I don't. I know that Lorraine, who's one of the marketing people with Percona, said that there was a cancellation, but I don't know what happened, and so they had shifted me up. So yeah, the paper is incorrect now, and the app is correct. I don't. Now, if you wanted to talk to me about maybe GaussDB or Cockroach or some other stuff, I could talk to you, but I haven't looked at Foundation DB that much, so I can't really articulate any ideas, other than I was going to attend that talk. No, they just shifted this one forward. They didn't tell me about any replacement one after my talk. So I think what they were doing is trying to keep y'all from having a gap, just a random 25-minute gap that didn't make sense to anybody. All right, thank you.